Hey everyone! Woo! So in this video, if I can get the screen to come up correctly, in this video we are going to do a sample calculation, and I'm going to show you guys how to pull the information that we went over in the first video, what you need to know in order to do a calculation. We're going to pull that information and try to make some sense of it. So let me get my highlighters here, wherever they are. There they are. So the first thing we need to do anytime we're doing a calculation is to decide which formula to use. And hopefully you remember from our other notes that if we are seeing a change in temperature, we use mcAT. A phase change is going to be HF or HV. So I'm going to read this question here, and if you want to pause the video and write the question down so you can work at the same time, you can feel free to do that. So after reading through this question, I have decided that I am going to use the mcAT formula. And the mcAT formula is used when there's a temperature change. And I see that the sample was at this temperature, and it's wanting me to find my final temperature. And both of those together are going to give me my delta T, my change in temperature. Okay? So right away off the bat, I know it's the mcAT, so MC delta T. So I'm going to set up my other variables. I'm going to have my Q, which is, remember, Q is energy or heat. So if I look, heat capacity, so okay, 65,000 joules of energy. So I know it's Q because Q is energy. I also know it's Q because joules are the units of energy. So there's a couple different ways we can look at that. So 65000 joules. What else do we have? So Q equals MC delta T. So my M is going to be the mass. And mass is 450 grams. And if you guys, just a reminder, if you're not sure where I'm getting these numbers from, go back and watch that first video because I walked through each of the variables and what they represent. So if you're like, I don't understand how she knows why M is mass, go watch that video and you will hopefully understand. We have mass, and then finally our C, before we can get to our delta T, our C is our specific heat capacity. And it does say that the heat capacity of iron in this case is 0.447 joules per gram degree Celsius. So 0.447 joules per gram times degrees Celsius. Okay, now I didn't fill in my delta T. And that's because it doesn't just say what's the change in temperature. It wants to know what my final temperature is. And so instead of writing delta T equals, I'm going to put up here T final minus T initial. That way I know what I'm actually looking for. So this is going to give us that, right? So I don't need to worry about this anymore. And from here, I can fill in that 20 degrees is my initial temperature. So it's going to be X minus 20 degrees Celsius. So we've identified all of our variables. Now from here, we just need to plug them in and get an answer. I wish, oh, here's my calculator. Okay, so I got a calculator. And I need a black pen. Here's my pens. So go ahead and pause the video, try to set this up, figure out what numbers go where, and then go ahead and calculate it and see if you can get an answer. And if you want to check each step, just pause the video after I write the next step and see if you can follow along. So I'll start here by just plugging them into the formula. Remember, the formula is Q equals MC delta T. Okay, if you pause the video and replayed it, now hopefully you have gotten to this point. All I did was plug in my numbers to the Q equals MC delta T. So I have my Q, my M, my C, and my delta T. Now go ahead and pause the video again if you haven't already and try to get the answer. And I will show you my work as I go. So I'm going to start off by just multiplying these two, 450 times 0.447. And just so you guys know, I am going to write down the number here, but I'm not going to retype that number in my calculator. So right now it gives me 201.15. So just double check my math, 250 times 0.447, 44, yep. So I get 65000 equals 201.15 times x minus 20. Now I'm not going to retype that number in, that 201.15. If I do, I risk typing it wrong. And sometimes we get numbers with like a million decimal places. And so we don't want to round as we go. And I know that the next step is going to be dividing both sides by that 201, so I can start to isolate x. So 201.15, and then this is going to be divided by 201.15. So what I'm going to do is I'm just going to say 65, and hopefully this is not a calculator that I want to use. Hang on, let me see if I can. Here we go. This is a better calculator. This is what you'll use in class. I don't know how that one works. I know how it works. I just don't know if it's going to do what I want it to. Okay, try this again. So 450 times 0.447. Okay, so there's my 201.15. So now instead of retyping it, I'm just going to say 65000, 65000, can you guys see that? Divided by, and I'm just going to push this up arrow, highlight it, and push enter. And that's going to bring that number down so I don't have to retype it. And that's really important, again, avoiding mistakes and things like that. So 65,000 divided by that 201 is going to be 323.14. So 323.14. I'm sure you just heard the bell ring, so I'm going to try to finish this quickly. And that equals x minus 20. So now to get x by itself, I just add 20. And again, I'm not going to retype that number. I'm just going to push plus and then 20. And I get, oops, I did multiplied by 20. Whoopsie. I'm going to do 323 again. So I just pulled it from up there, plus 20. Oh, much better. So I have 343.14. And then the units for this one are degrees Celsius. And that is our final answer. Hopefully that's what you got. And that is how you use the mcAT equation, how you identify when to use it, and what each of the variables looks like when plugged in. Thank you.